AQA Core Maths Level 3 Certificate, June 2016, or Mathematical Studies, Paper 2C, Graphical Technique. Question 1. Use Facebook facts on page 2 of the preliminary material, which is on the right-hand side. According to the article, Facebook had 1,230 million monthly active users worldwide by the end of 2013. Circle 1,230 million written in standard form. Well, the best way to do this is to write that in standard form. So 1230 is 1,230. Million means times 10 to the power of 6. I need to write 1,230 in standard form. So the point to the right is there. So I'm moving that point to the left. 1, 2, 3. So I'll move it 3 times. So that'll be 1.23 times 10 to the power 3, because I'll move it 3 times. I also add 10 to the power 6, which was there before, so I'll just write that down. Now I need to write 10 to the power 3 times 10 to the power 6, because they have the same base, and when multiplying them, we add the power. This is the law of indices, which says that a to the power of n times a to the power of m equals a to the power of n plus m. So in this case, I'm going to have 1.23 times 10 to the power of 9. So on the left hand side here, I'll look for 1.23 times 10 to the power of 9, and I'll circle that. That's the answer. Question 1b. Suggest 2 improvements that could be made to the presentation of the bar chart in the article. So the article here is on the right hand side, and 2 improvements that could be made. Improvement 1. Well, on the axis, there weren't any label, so we could label the horizontal axis and the vertical axis. So we could label the x-axis and the y-axis, because there weren't any form of labeling there. So that's that. The second improvement could be that we could improve the title. So we could improve the title, or / we could make it clear what the numbers represent. What the numbers represent. So those are that's what a number represents. That's what we could do. We could also correctly place the year before the numbers of users. We could also use key to indicate, for instance, M stands for millions. So that could also help. Question 1c. Joe has just started working for Survey Hunt, a social media research company. Joe calculates the mean increase in the number of active Facebook users per year from the beginning of 2008 to the end of 2013. His calculation is as follows. Right, so Joe is trying to calculate the mean. Critically analyze Joe's calculation, stating any correction or improvement that could be made. So from these calculations, Joe is looking at these values and then working out the mean starting from 2008. And we can see 145 here and 58 million, 145 million, 360 there, and also 608, but Joe wrote 680, so that was a mistake there. So 608 instead of 680 was written. So it should have been 608 minus 360. So making reference to that one. It should have stated a number of the numbers in M or millions. So it should have stated the number in M or millions or 10 to the power 6. The denominator should be 6, not 5, as seen in the calculation, because we've got 1, 2, 3, 4, 5, 6 here. So the denominator should be 6, not 5. Also, what can we see here? We can see that he could use a quicker way to do the calculation by using the final value minus initial value and then divided by n. So in this case it would be, or it could have been 1230 minus 58 divided by n, which is 6. So that's what he should have done. He should have stated the answer, or the answer, because the answer is not given. So he should have stated the answer, which is not shown. Question 1D. Just before Facebook bought Instagram, Facebook had 900 million users. As part of the purchase, each Instagram users were automatically given a Facebook account. On 10 April 2012, Survey Hunt carried out a survey about the public's opinion of social media. A sample of 350 people with Facebook account took part in the survey. Of these 350 people, 25 were Instagram users who had just been given a Facebook account. Survey Hunt claimed that its survey fairly represented the Instagram users who had just been given a Facebook account. Does that data support the claim? We need to show our working well. So because the Instagram users were, at the time of the purchase, they had 40 million active users. So they would have 900 plus 40, that will give them 940 altogether. So from the survey, 25 out of 350, and then the real figure should be 40 out of 940. So that's a total number of Facebook users and 40 from Instagram. And the ratio of these two gives 0.0714, and the ratio of the 40 over 940 is 0.0426. So this one is, if you multiply by 100, is 7.14 percent, and this one is 4.26%. These are not equal to each other, so they're not equal or similar. So I would say not equal or similar. So therefore, what we can say is that we can say that the data does not support the claim. So data does not support the claim. So that's what we can say. Question 1E. On 4th February 2014, Lena had 50 shares in Facebook. The exchange rate that day was £1 equals $1.6. She said, quote, "My shares in Facebook are worth more than £2,000, unquote. Was she correct? You must show your working." Right. So the current share on Facebook is $61.48. So one share equals $61.48. So to convert that to pound, with the exchange rate, one share will be worth $61.48 divided by 1.6 in pound. So that's what this one share will be worth. In this case, now what we now need to do is find how much is 50 shares. So 50 shares will be times 61.48 divided by 1.6, and that will be 1920.25. 1920.25 pennies. Therefore, she is wrong or not correct. Question 2. Use global adultery literacy on page 3 of the preliminary material. So we've got this information on the right hand side. Some numbers of UNESCO suggested that the data had not been presented well. Gave one reason why they might suggest this with regard to figure 1. Okay, in the figure 1, the shapes seems to be overlapping and they're too close together. So we can say the shapes such as the circle and the triangle and the square, they seems to be too close together. They're too close to each other. So, or overlapping. So that's one good reason. Another reason, give one reason why they might suggest this with regard to table 1. So table 1, in table 1, some data were not shown or they're missing, such as the population. So in table 1, some data some data were, I used were rather than are, some data were missing or not presented clearly. Some data were missing, such as the total population, i.e. total population. Question 2b. The two statements below were made on an online forum discussing adult literacy rates. The number of literate adults in the world in 2012 reached nearly 4.2 billion, said Paul. Central Asia has made the greatest progress in improving adult literacy over the past 2 decades, said Rina. Critically analyze these two statements. Show working to justify your comment. So regarding Paul's statement, the adult literacy rate total is 84.3%. And the illiterate population is 781 million. So if the literate rate is 84.3, the illiterate will be 100 minus 84.3, and that equals 15.7%. That's for the illiterate. So we're trying to work out the population of the literate from the population of the illiterate. If the illiterate population is 15.7%, and those 15.7 was 781 million, so what we can say is you can work out the whole population by saying 781 divided by 15% is actually 15.7 over 100, which is 0.157. So if we divide that by 0.157, we will get, I'll divide that now. So 781 divided by 0.157, we get 4974.52 million people. So that's 4.97. So that would be 4.974 billion. But the population So that's nearly 5 billion. And so, but 84.3 are the literates. So that's nearly 5 billion, but 84.3 are the literates. So we do 4974.52 million, or 522, let's just make it more accurate, times 0.843. So if we times that by 0.843, we get roughly 4193 million, which is roughly 4.2 billion. So Paul's statement was correct. So Paul is correct. Question regarding real estate. The graph doesn't cover 20 years period, so cannot use the 20 years or 2 decades. 20 years is 2 decades, because the graph does not support the data. So the graph does not support the suggestion. Because also the region, also other regions made greater progress. Made greater progress. The Central Asia has made least progress in terms of rising percentage. So we know that. So any of these points will do. Question 3. Consumer of electricity have to decide which payment plan or tariff to follow each year. Tariffs usually consist of a charge per kilowatt hour of electricity use and an annual standing charge, a fixed fee that is payable no matter how much electricity is used. The table below shows 3 tariffs that are offered to consumer. Right. Question 1, 3A. Show that using 1000 kilowatts in 1 year with tariff B will cost £180. So the tariff charge B for 1000 kilowatts, and charge is per kilowatt, so 14p per kilowatt. So that would be 14p is 0.14 in terms of pounds. And if you times that, so that's pounds. If you times that by 1000, and then we add the fixed cost, which is £40, that's fixed. So we would get 140. So that will give us £140 plus £40, and that made a total of 180 pounds. Question 3b. Eva is employed to advise consumers about the cheapest tariff for them. The consumers she advises use between 1,500 kilowatts hour and 3,500 kilowatts hour per year. She needs to know which tariff will be cheapest for different amounts of electricity used. Advise Eva on which tariff to suggest to customers depending on how many kilowatt hour of electricity they expect to use in the next year. You may use the grid on the opposite page to help if you wish. This question is 9 marks. It's quite heavy, so let's start. The best is to draw a relationship between the variables here. Tariff A is the first variable we look at, and tariff A is, let's call the variable y equals 0.16x. So that's the first variable here. Let me just write it clearly. And that looks like y equals mx. And the tariff B is y equals 0.14x plus 40. So that's the second variable. And tariff C, y equals 0.12x plus 100. So that's B and C looks like y equals mx plus c. So two ways we can solve this. We can find the intercept between A and B and intercept between B and C, or even intercept between A and C. So two ways we can do this. I've decided to use the graph to solve this because we had we basically have this graph paper, so I don't want to waste it. We could solve it by simultaneous equations, or just solve it by or using these graphs. So let's use the graph. For tariff A, where y equals 0.16x, when x equal to 0, y equals 0 as well, because 0.16 times 0 is 0. When x equals 1000, y equals 160. For tariff B, when y equals 0.14x plus 40, when x equals 0, y equals 40. And when x equals 1000, y equals 180. 140 plus 40, so that's 180. So what we did was substitute x in, so that becomes 0.14 times 4 times 1000. So that gives 140. 140 plus 40, that's 80. For tariff C, when y equals to 0.12x plus 100, when x equal to 0, y equals to 100. And when x equals 1000, y equals 120 plus 100, so that's 120 plus 100, that equals 220. Now we can plot the graphs on the graph paper here. So when x is 0, y is 0, 0 is the first point. In second point, you need to point to plot a straight line. When x is 1000, y is 160. So that's 150, 160 here. So we can draw that straight line. So let's make sure it goes through the point. Right, so that's the first equation. That's tariff A. Now, the second point, tariff B. When x is 0, y is 40. And when x is 1000, y is 180. So that's that point there. Right. Now let's plot the third one, tariff C. When x is 0, y is 100. And when x is 1000, y is 220. So drawing that will be there we go. That'll be an intercept there. That's there. So we straighten it properly. Making sure it goes there. There you go. So that's done. So that's tariff C. And this is tariff B. We can set the intercept between tariff A and B at 200. So that's first intercept here at 200. And between tariff B and C at 3000. And between tariff A and C at 2500. Those are the 3 points of interception. So the advice for customer will be so tariff from the graph, tariff A will be when x is less than 200. So when x is less than 200, it's for tariff A. Tariff A is better. So that means the tariff will be between 0 is less than x is less or equal to 2000. Sorry, not 200, 2000. So that's tariff A. But tariff B, for tariff B, will be between 3. So I think tariff B will be between 2000 and 3000. That's what tariff B will do. So tariff B will be between, say, 2000 is less than x and it's less or equal to 3000. So that will be tariff B. And tariff C, for tariff C is going to be, right, so that will be greater than 3,000 basically. So tariff C is when X is greater than 3,000. So we could say between 3,000 less than X or less or equal to 4,000. So that's tariff C. Right, so those are the advice to give to Anna. Question 4a. The graph below shows the average annual cost of gas per household in the UK from 1st of January 2006 to 1st of January 2008. Calculated daily. Y is the average annual cost of gas in pounds per household in the UK. X is the number of years after 1st of January 2006. We got this curve that's been given to us. It looks like a quadratic with a minimum, which means that A is positive. So let's read on. For example, on 1st January 2007, the average annual cost of gas per household in the UK was 560. Sam believes the average annual cost of gas for this period can be modeled by the quadratic function y equals a open bracket x squared minus 2x close bracket plus c, where a and c are constants. Calculate the values of a and c. Right, so let's just describe this quadratic curve we've got here. This quadratic curve is basically similar to any quadratic curve, which is, in this case, we've drawn this one now, so that's what we've got. In this case, the point of intercept on the y-axis is c. So what I'm saying is a general equation for quadratic is ax squared plus bx plus c. And the intercept on the y-axis is c when x is 0. So that value here is your c, and that value here, it's your x when x is 0, that's 0 there, and y is c, which is 640. At the turning point here, at the turning point is the minimum value, at the turning point where you can get your x and y values. So your 1 is your x at the turning point, and your y at the turning point is 560. So we're given the modeling equation. What we need to do is basically solve that modeling equation using completing the square so that we can find the turning point. The turning point, or completing the square, so if I write completing the square, it gives us the turning point coordinate. So the x and y are the coordinates. So that's what completing the square does. So that's why it's good to use that method. And so that's what we're going to do. We know the value of c is 640 now. We just need to find a. So let's do that using completing the square. So we got a curve, a into bracket x squared minus 2x close bracket plus c. So to solve that, we need to basically solve the bracket using completing the square. So we keep the a, open bracket, x minus 2 over 2, so that'll be 1, squared, minus square of 1, the square of 1 here, and that'll be 1 squared is 1, close bracket, it's important you do that. So the completing the square is used only for the first two terms here. And that's why we close the square bracket. And then we bring down the c. So now that we've done that, what we need to do now is now open the square bracket and multiply everything by a except c. So you're going to get a into bracket x minus 1 squared minus a plus c. So now this is the completing the square solution. In this case, x at the turning point, so I'll put at the turning point, x will be equal to x minus 1 equal to 0, and therefore x equals 1. And we can see that here at the turning point, x equals 1. X equals 1. At the turning point, y will be equal to minus a plus c. So we know the value of y. The value of y at the turning point is 560. Here, that's y at the turning point, 560. So we write 560 equals to minus a plus c. And we know the value of c is, the c is 640. That's your c there, 640. And so we put 640. So the next thing we need to do is rearrange and then find a. Well, with that expression, let's just write the a again. 560 equals minus a plus 640. Add a to both sides and take away 560 from both sides. We're going to get a equals 640 minus 560. And therefore, my a will be equal to 80. So in my answer box, I will put 80 for A and 640 for C. And that's how you solve that. Question 4b. The graph below shows the average annual cost of gas household in the UK for a different time period from the one shown in part A. Sam wants to use a mathematical function to model the average annual cost of gas as shown by the graph. Which type of function would be suitable for this? Circle your answer. Well, we know what linear graphs are. Linear graphs are basically just a straight line. That's linear. Quadratic, we know what quadratic are. It's basically like that. Cubic, we know what cubic are. They're more like that. So they have a two turning point. Not one, two turning point. Quadratic has one turning point. Cubic has minimum two turning point. An exponential function are basically a function that just grow exponentially. So that's exponential function. So we can check which one is similar to the graph above. You can see it's cubic. So therefore, we circle our answer to be cubic. Right. Question 5. A scientist is studying a colony of bacteria at time t minutes. There are n,000 bacteria in a colony. The scientist models n using an exponential function. N equals to e to the power of t. So that's the exponential function. On the axis below, sketch the graph of n against t. Give the coordinate of any points where the graph intersects the axis. So, this is kind of interesting question. It's very tricky. So basically, the graph is n equals e to the power of t. The reason why they're asking you to give a coordinate is anytime you're sketching any graph, in this case, t is the x-axis. So that's your t, that's the x-axis there, that's t. And y is n is your y-axis. So therefore, when t equals to 0, that's what they're asking you to do, find the value of n. So therefore, n equals e to the power of 0. Anything to the power of 0 equals 1. So therefore, n equals 1, which implies that n equals 1, because e to the power of 0 is 1. So at this point, when t is 0, you're going to have 1 here. And then, so therefore, you sketch your curve, so it will go up like that. So that's what they're expecting you to sketch. And that's it. The coordinate at this point is 0, 1. That's the coordinate there. Question 5b. Work out how many minutes it will take for the number of bacteria to grow to 90,000 colony. In this case, we're told to find the time. We know the modeling function is n e to the power t, so it's an exponential function. We use logarithm to solve exponential functions. The word solve means make x equals or make t equals. So in order to make t equals as the subject, make t the subject, we use logarithm. In this case, we need to take log of base e because we're dealing with exponential function with base e. So therefore, we need to take log of base e, which sometimes is written as natural log. Log of base e is natural log, n for natural, l for log. In this case, so we're going to take log of base e. So let me just draw a line here so we can separate what we're doing. In this case, it's going to grow to 90,000, so that means n equals 90,000. But before I put in the value, I'm going to make t the subject using natural log. So I'm going to, on both sides of this equation, I'm going to put ln n equals e to the power ln e to the power of t. In a log, we have this behavior. If you have a log of base a, and then you have x to the power of n, we can write it as n log of base a x. So the power will come to the back of the log, and that's how we write. This is called power law. Power law in logarithm. So we're going to use power law here. So that will become ln n equals t ln e. Now, also a good thing to remember is log of a to a equals 1. In this case, log of e to e equals 1, which is also equals to ln e. And therefore, ln e is 1. So therefore, I have my t equals, because ln e is 1, 1 times t, that's t. So t equals ln n. To find the value of t when it grows to 90,000, so you put ln 90,000, and that will be your answer. So t equals ln 90,000. If you plug that into your calculator, you will get 11.4 minutes. Question 5c. At what rate per minute is the number of bacteria growing when there are 90,000 bacteria in the colony? Well, the rate here is going to be n over t, so the number of rate per minute. So basically, it's growing at 90,000 over the time of 1 minute. So the answer will be just 90,000. Question 5c. At what rate per minute is the number of bacteria growing when there are 90,000 bacteria in the colony? So this is a trick question because we already found out that n equals to e to power of t. So we want to find the rate per minute. And in that case, the rate per minute is the n over t. And we already worked out our result that so what that meant is t equals n 90,000, right? So the rate when there are 90,000 in there, so what we need to do is find the n when e of ln, let's replace t by ln 90,000. And from the calculation, e ln 90,000 will give you 90,000. So it's a trick question, but you could use your, again, natural log to find the value or to the answer there. So that's what this is. So this is 90,000 per minute. Question 6. The distance time graph below represents a car that is overtaking a lorry on a straight road. The speed of the car is constant during the first 2 seconds and the final 2 seconds. This is a distance time graph, and the gradient of a distance time graph will give you the speed. And the first 2 seconds obviously is a uniform speed. That means the gradient is constant. And the last 2 seconds is also a uniform speed. That means the gradient is constant. So we need to work out the average speed of the car during the 12 seconds. That means we need to work out, that's the total distance travel. The average speed is the total distance travel over the total time taken. So let's just write that down. Average let's just write that clearly because I can't spell now. Average speed equals total distance travel over total time taken. In this case, total distance is 120 over 12. And that will give us, well, 12 cancel there, 1, 12 cancel there, 1. So that will become 10 over 1, which is 10. So the answer is 10 meters per second. Question 6b. Use the graph to estimate the maximum speed of the car as it overtakes the lorry. Where maximum speed of the car is the steepest gradient, basically, and the highest gradient. That's what I meant. So if we go back to the graph, we need to find the steepest gradient. There's a steep gradient here, but not the steepest, 0.1. 0.2 might be the steepest, and there's 0.3. So in this case, I think the steepest gradient is 0.2. So if I draw a straight line across there, I'm looking for a good solid straight line there. Okay, so that's a good one there. So I'm trying to make it as straight as possible. Okay, so let's assume I've taken my straight line, or I've drawn a tangent at 6. And this tangent, I want to basically pick up 2 points on the curve. So I've picked up that point. And another point maybe here. And so I just want to draw a straight line So I haven't done a perfect straight line, so I'll do another one. So roughly that's a straight line there. And I want to draw another one there. This is not very good, but it's all right. Okay, so that's an estimate really. So let's assume that's 100 at that point, and this is 40. And the distance between the two of them is 100 minus 40, and that will give us 60. So that height is 60. And that width here is, this one is 9, and this is, well, each little square here is 0.2 because I've got 10 that fill in the, from 0 to 2. So there are 10 little squares. So I'll put 10 divided by 2, that's 0.2. So each little square is 0.2. So if this is 4, 4.2, 4.2, 4.4, 4.6, 4.8. So this is 4.8. So that would be 8 minus 4.8. 8 minus 4.8. So that's my little square there. And so I just go onto my calculator and do 8 minus 4.8, and I get 3.2. So this length is 3.2. So 60 divided by 3.2. So if I go 60 divided by 3.2, I may be getting 18. So that's 18.75. So that's 18.75. So that will be my gradient at 6. So I draw a tangent at 6. And from there, I get my gradient. It happens to be 18.75. So when I come back here, my highest gradient, so the highest gradient will be the maximum speed. So in this case, it's 18.75 meters per second. So I'll put 18.75 meters per second. Question 6C. Sketch a graph to show the speed of the car as it overtakes the lorry. Well, to sketch a curve, we need to go back to the graph and look at it carefully. There are 3 points, remember, as has got different stiffness. The first one is at point 1. We can work out the gradient between their point and this point here. We can work out that gradient. And that gradient is 10. The height is 10 and the length here is 2. So the gradient there is going to be 10 over 2, which is 5. That means between 0 and 2, it's a constant speed of 5. Constant speed of 5. So we need to draw this. So if that was 10, and that's 20, that's 30 and 40. So at 5 is a constant speed between 0 and, so that's a constant speed. Let me just draw that clearly. There you go. So that's a constant speed, that's 5. Now, at 6, we already found the gradient at 6 equals 18.75, because that's where I draw the tangent from. So 18.75 will be, so that's 15 here, 15, 16, 17, 18. 18.75 will be somewhere there. So that's a curve. That's the maximum, right? We're assuming that's the maximum point. That's a curve. And then this will just go up there to meet the curve. And then between, so that was the gradient we found at 6, the tangent. And then between 10 and 12, we have another constant speed. Constant speed. So if I draw my line from there to there, if I like, let's assume that, and I can work out the height here. So the height here is going to be roughly, so there are 10 between 20, so each little point is 2. So that's 2, 4, 6, 8, 10. Yes. And 12, 14, 14.14, 15. So that's 15. And the length is, each little point is 0 0.2. So 0.2, 0.4, 0.6, 0.8, 1. 1.2, 1.4, 1.6, 1.8, and 2. So you can see that's 2. So that's 15 over 2. That's 7.5. So that's 7.5. We go back to the graph. We know now between 10 and 12, it's a constant speed of 7.5. So that's 5, 6, 7. So that's 7.5. That's a constant speed. And now let's just draw a thick line. Oh, it doesn't like that. Oh, I'll draw another thick line. My hand is kind of shaky. There you go. And now we can draw our curve to meet that line. So that's the diagram from there. At this point is x is, time is 6, and that's 18.75. Okay, and this is 7.5 constant, and that's 5 constant. That's drawing the graph or sketching the speed of the distance time graph. This is speed time graph. Question 7. Lily is a parachutist. She jumps from a static balloon and falls vertically through the air. Before her parachute is open, Lily's speed is v meters per second at time t seconds after leaving the balloon. Is modeled by this equation: v equals 55 open bracket 1 minus e to power minus 0.2 t close bracket. Lily opens her parachute after 3 seconds. Work out Lily's speed as she opens her parachute. Well, so basically, she opens the parachute after 3 seconds. So that meant that t equals 3 seconds. So we need to work out the speed when she opens the parachute. So we're just going to do v equals 54 into bracket 1 minus e to minus 0.2. And then we need to replace t by 3. So that's times 3, close bracket. So let me just do that properly because it doesn't seem clear. So that's times 3, close bracket. And then we're going to get, we need to punch that into our calculator. So if we do that, we just do 54 open bracket, then put 1 minus, you need to do shift ln, ln is above, ln is below x and above tan. So you need to do shift ln to get e to power, and then you press minus, and then do 0.2 times, press times 3, and you need to move our arrow to the left and then close the bracket and press enter. So that will give you 24.4. So the answer is 24.4 meters per second. Right, question 7b. After the parachute has opened, Lily's speed reduces rapidly and can be modeled by an exponential function. Eventually, Lily's speed approaches 8 meters per second. Sketch a graph to show Lily's speed after she leaves the balloon. Okay, so if we recollect, the speed the velocity we're using is v equals 54 into bracket 1 minus e2 minus 0.2 t close bracket. Right. At time t equal to 0, if you put t equal to 0 in the beginning, so you're going to get v equals 54 into bracket 1 minus e to power minus 0.2 times 0. So 0.2 times 0 is 0. So v equals 54 into bracket 1 minus e to power of 0. E to power of 0 is 1. So that will be 54 into bracket 1 minus 1. 1 minus 1 is 0. 0 times 54 is 0. So at t equals to 0, v is 0. The speed is 0. Then you remember when t was 3, so that, let's say that was 3 there, we got the velocity to be 24. So let's assume that's 24. So we just sketch the speed will rise to 24 at 3. So that's the point. That's what's going to happen. And that will be at 3 equals to 3, and speed is 24.4. At this point, the speed eventually start to decline. So it will decline, and the question says it will decline to 8. So if that was 24, it will decline to 8. So that's what the question says. So we need to please read the question carefully. So it declined to 8. Okay, so that's what's going to happen. And so that's the speed we're going to get. We could work out the time that it will get to 8 if we wanted to. But we'll just leave it at that. So that's what we're going to get. Remember, v, because it says it approaches the line here. It approaches the line 8 meters per second. So the line 8 meters per second is the line of asymptote. So let's just spell that clearly. Asymptote. That's the line it approaches but never touches that line. Question 7c. When a parachute has been opened for 2 seconds, Lily's speed is 10 meters per second. So the clue here is 2 seconds and 10 meters per second. So that's the time at 2 seconds, and that's the velocity at 10 meters per second. Her speed, v meters per second at time t period, time t seconds, after the parachute is opened, is modeled by the equation v equals 8 plus be to minus kt, where b and k are constant. Work out Lily's speeds 2.5 seconds after the parachute is open and give your answers to 2 decimal places. So, well, when she was at the top, when t was 3, the speed was 24.4. So that's when the parachute started to come down. So that's a new time now. At that time, t is 0. So at that time, so what we need to remember is that at velocity equals 24.4, that's the time the parachute was released, which means it's a new start of parachute. So it's a new time starting at t equal to 0. So that's the beginning of the decline, t equal to 0. So the speed will slow down because the air resistant. So that's why the speed will start to reduce. So that's the beginning at t equal to 0. So when t is 0, we can find b actually, because if we look at the equation, v equals 8 plus b e to minus kt, and t is 0, so we get v equals 8 plus b e to minus k times 0, because t is 0, time is 0. And k times 0 is 0, so therefore I get v equals 8 plus b e to power 0. E to power 0 is 1, so I'll get v equals 8 plus b. But my v is 24, so I'll put 24 equals 8 plus b. In fact, 24.4. So therefore, b will be equal to 24.4 minus 8. So I take away 8 from both sides. And so I get, so 16.8. So I get 16.4. That's my b. So if I take that 16.4 and I put it back into the equation, so I'll get a new v equals 8 plus 16.4 e to minus kt. Now I know what my b is. As you can see how I found the b, you need to use the initial velocity at the point when the parachute was released. At that point, time t will be 0, a new time for the decline to start. Now I need to then use the values I'm given here in the question. T at 2 seconds and v is 10 meters per second to find k. I need to find k, so what I need to do is deploy or rearrange basically t, rearrange k, sorry, and find k. So we need to make k the subject. To do that, we need to use the logarithm to do that. But first, I need to rearrange the whole thing. So v minus 8 equals 16.4 e to power minus kt. I need to divide both sides. So I take away 16 from both sides. So let me just draw a line there and make it easy so you don't get confused. So I take away 8 from both sides. Now I need to divide both sides by 16.4. So I get v minus 8 over 16.4 equals e to minus kt. Now I need to take ln on both sides. So I have ln, put this in bracket, v minus 8 over 16.4, okay, equals ln e to minus kt. Now I need to use power law and bring minus kt in front of ln. So that will be ln v minus 8 over 16.4 equals minus kt ln e. But we know that ln e equals 1. So ln e equals 1. So I'm going to have ln v minus 8 over 16.4 equals minus kt. That's good. So let's just close this up. And so we don't get confused. Now I need to find, remember I need to find k. So I need to divide both sides by minus t. So I get minus 1 over t ln v minus 8 over 16.4. In fact, let me just write it clearly so you don't get confused. So I'm dividing both sides by minus t, and that will be ln, open bracket, close bracket, v minus 8 over 16.4 equals k. So that's what k will be. So now let's plug in the values. Minus 1 over t is 2 ln. So v is 10 minus 8 over 16.4, which equals to k. And that implies that minus a half ln, that's 2 over 16.4. So let's use our calculator to do that. So ln, it's right in the middle between x and tan. So you just press ln. It has the first open bracket. Do the fraction button, which is in the middle between option key and minus, and put 2, and then arrow down and put 16.4, arrow out, and then close the bracket, and then press enter. So that'll be minus 2.1, and times that by minus 0.5, because a half is 0.5, and the answer will be 1.05. So k will be equal to 1.05. So that's the value of k, 1.05. But the question is asking us to find where k and b are constant. The question is saying, work out the value of speed at the speed at 2.5 seconds when the parachute is opened. So we know what the value of k is, so we can put it back into the equation. So that'll be v equals 8 plus 16.4 e to minus 1.05 1.05 t. So that's it. So to find the value of work out the value the speed at 2.5 seconds, all we need to do is replace t equals 2.5 seconds to work out the speed. So we do v equals, that's the speed, equals 8 plus 16.4 e to power minus 1.05 to times 2.5. So t is 2.5 in this case. So I do 1.05 times 2.5, and let's take minus in there. So that should delete that. Okay, so times 2.5, or just write it properly, just do 8 plus 16.4, and then you need to do shift E, you need to put minus, and then put open bracket 1.052, I think, just times 2.5, close bracket, press enter. So that would be 9.81, and the answer is in 2 decimal places, so the speed will be 9.18 meters per second.